When you come in for class, the lab should already be set up for you. So the ramp should be there, the motion detector should be where it should be, the LabQuest should be hooked up. There should be an index card attached to your little cart, and it should be sitting nearby. So the first thing you want to do is just pick up that motion detector and move the switch. You can see right here, ooh, that's not what I meant to do, sorry. Right here, you can see that that's where that switch is, and there's a basketball and a cart. You want to put it on the cart side. In this picture, it's on the basketball side, but you want to move it to the cart side. It might already be there, but make sure that it is. So that's just step one. Then you want to go to that LabQuest screen that I was telling you about before and click on the rate. So make sure, hit the home screen, make sure that the LabQuest is showing you this screen. And then what you want to do is you want to click on the word rate, and that'll bring up another screen. And what you can do is you can type right into that screen that you want 5 samples per second and a duration of 3 seconds. So it looks like this when you're done. The next step is to collect data, but this is going to take you a while to figure out exactly how to do this. So what you want to do is you want to place your car on the ramp with its front wheels so that they are on the 1.5 meter line. So the ramp will be marked off with 1.5 meters and other distances. So you find the one that's marked 1.5 meters, and you want the front wheels to be just lined up with the edge of that tape. And then you want to hold your car in position with just one finger beneath the front wheels. So you're going to stick your finger right there. Just going to hold your finger there. Here's your finger. There it is. And when you do that, you're going to see that on the LabQuest, it's going to give you a reading for the position of the cart. And if you manage to hold your hand steady enough, it'll give you a steady position. That's what you're looking for. You want to check to see what that position is. It should be around 0.3 meters. It's about 30 centimeters away from where the end of the wheels are. So the motion detector is going to be measuring how far away your cart back wheels are. We're actually going to be measuring how far away your reflecting surface is from the actual motion detector, right? So that should be about 30 centimeters or 0.30 meters. But it's not going to be exact. It's going to depend. So what you want to do is you want to make sure that every time you run the test at this distance, that you're always starting at exactly that point. And to make sure of this, you'll have a data table that asks you every time what your starting position is. And you're going to record that information in your data table. The data table refers to that starting position as distance from the motion detector in meters. And it'll be around 0.30 meters for your first release point. So you're going to always start there. Now, what you want to do next is you want to start collecting data. To do that, you have to click on the green arrow on the bottom left of the screen on the LabQuest. Here's that green arrow. It's right down there. You're going to hit that, and when you do that, here's what's going to happen. You need to listen carefully for the motion detector to stop clicking and then restart clicking. So as soon as you hit that little green arrow, you'll hear some clicking and then you'll hear it stop for a second. Do not release the car until the clicking starts again. Then you release the car. So you're not going to move your finger until you first hear clicking, then stopped clicking, then it starts again. So it's click, 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 click. As soon as you hear the restart of the click, that's when you release. Getting that timing down is a little bit difficult, especially since you're probably going to have one person hit the green button and another person release the car. And I recommend that because trying to do it by myself is really hard. So I think it'll probably be easier if you do it one person hitting the green button, one person listening for the release time. And then after you do that, you want to look at your data and see if the data looks smooth or crooked. Oops, I shouldn't have said crooked data. What I meant was jagged data. If you look at this blue line on the bottom, that nice smooth blue curve, that is what we call smooth data. And it's smooth because it looks like a hill looks. It doesn't really have any extra bumps in it. If you get data though that looks like this, that's kind of a problem. That means that something went wrong with your test, probably some kind of friction or interference, or your cart's not going straight, something like that. So any tests like that you want to ignore just like they didn't even happen, because that's definitely a source of experimental error, and you want to start over again. However, if your data is nice and clear, like this one, and you like it, then the next step is to figure out what is the maximum velocity. What was the fastest velocity that your cart had while it was running down that hill? And the way that you do that is you actually take this little circle, see that little circle there? You can actually put your finger right on the LabQuest and move your finger to that position. And when you do that, it'll then bring up over here the exact velocity of that position. And that's the information you're going to record in your data table. So you're going to do, for trial 1, you're going to write down your data for your first smooth piece of data. It might take you a while to get smooth data. That's okay. That's totally normal. So then you're going to write all 3 digits, 0.541, whatever it is, meters per second. Your data table has no units. I'm sorry, it does have units across the top, so you don't have to squeeze the units into those tiny little boxes. You can just write the numbers. And then you need to repeat the experiment at that distance, because if you don't, how do you know that this is a good piece of data? You need precise data to know if your data makes sense. So you're going to repeat the experiment, and you're hoping that your result is going to be within a certain range of precision of your initial test. So what you're looking for here is that your data is about 0.30 meters per second away from each other. So you don't want your range among your data points to be any bigger than 0.30. And that's actually kind of a big range, but that's because this is a very difficult experiment to do with the equipment that we have without allowing that range. So 0.30 means that if the next time you do this, you were to get 0.841, believe it or not, that's close enough to the first number to be considered precise. And then if the next time you were to do it, you were to get 0.241, those 3 things are actually close enough together. They would be the furthest apart as they can be from each other. Well, actually, that's not true. These 2 are close enough together to each other, and these 2 are close enough together to each other, but the top one and the bottom one are too far apart. I apologize, because you can only have a total range of 0.30, right? If you have 0.841 minus 0.241, that's a 0.6000 range. That's too big, right? So what you want to do is you want to repeat your experiment until you have at least 3 data points that give you a range no bigger than 0.30. And if you do that, then you can, once you have those 3 data points, you can circle them in your data table and take the average of them, and we'll call that average our data point for that height on the ramp. Then you're going to repeat the experiment at the other 2 heights on the ramp, and you'll do the same exact thing. Finally, after you have all your data, you're going to create a graph. And you have a couple different ways you can do this. I'll show you some graphing problems that are on your iPad. Just call me over, I'll show you what I've got, or what you've got, actually. And there's some web-based ones you could use too from your iPad. But it's always a good idea to first draw out your graph by hand so that you know what you want your final graph to look like on the computer. And also, it's good for your brain to practice making graphs with your hands, even if you're drawing them on the iPad in some app. That's okay, but you should do this step. Basically what you want to do is you want to put on the x-axis, which is this one here, the horizontal axis, you want to put your average, you want to put plot release point down there. So you're going to put the release point. That's where you released your cart from in the experiment. So that's going to be in meters. And then on the y-axis, you're going to plot velocity of the cart in the units meters per second. You need a title for your graph, and I always like to make my title be a combination of my x and y axis. So this is the effects of release point on velocity of a cart. I'm not going to write all that up here, but you certainly can. The effects of release point on velocity of a cart. And that's probably the best way to make the title for any graph like this. And then what you're going to do is you're actually going to, create a scale. So you'll need to know what your furthest distance was in your release points, and then break that up into nice units so that they fit nicely on your graph. And you need to know the same thing about your velocity. What was your highest velocity? What was your lowest velocity? And you can fit those on your y-axis. And then you'll just graph those points. Now, I'm not going to graph them here for you, but I want you to think about, before you even do the lab, what do you think the shape of this graph is going to be like? As we increase the release point, as we go further and further away from the motion detector, or lower on the ramp, if you want to think of it that way, what's going to happen to the velocity of the cart as we change where we release it from? If you're high up on the cart, what happens to the velocity versus if you're low on the ramp? If you're higher up on the ramp versus lower down on the ramp, when you release the cart, what will happen to the velocity? You probably have a pretty good guess already. And you want to graph your data, and then you're going to write a conclusion for the velocity lab. When you do that, you're going to need your template that I gave you, or the list that's given to you, the bulleted list that goes ahead of that on the top of it. And remember what I said about making sure you challenge yourself. You can use the template if it feels right to you, if that's you can't do it without it. You just can't organize it without it. But if you're pretty good at organizing your thoughts, just go off of that bulleted list, because it'll improve your writing to do that, and it'll be more your own words, and that's a good thing for you guys. Okay, I will see you in class. Good luck with the velocity lab. I shouldn't have said crooked, I should have said bumpy. The data on the bottom in the blue graph is what we call smooth data. There's a nice hill-shaped lump. What you don't want is something that looks like this. You don't want jagged data. If your data is all jagged and like rocky and bumpy and up and down like that, that means something's going wrong with the test. Probably you have some kind of obstruction on your track, or you're releasing in a way that makes it hit the sides of the track, and so that's making the cart speed up and slow down and do weird things. You don't want that. So if you have run the test and you get smooth data, awesome. The next step will be to use that data to fill in your data table. So what you want to look for is the highest point on the graph. And you can actually put your finger right onto the LabQuest and move this little circle to the highest point on your graph. And then it'll show you the velocity at that point over here. And that's the data you want to record in your data table. That's how fast your cart was going on average when it was released from that point on your ramp. So you're going to put that into your data table. Now, one test is never enough for a valid test. So you have to repeat these exact procedures again. And you want to repeat it at least 3 times. You can stop after 3 times if each time you do it, you get precise data. Precise for this experiment is within 0.30 of each other. So, whoops, 0.30. 0.30. So that means that if the next time you do this, instead of 0.541, you get 0.571, that's 0.30 away. That's good. You can keep that data point. If you get something like 0.73, no good. That's too far away. 0.30. Oops, my bad.